Our topic is linear programming. Linear programming. So if you look at the topic, linear, it means we are plotting straight line graphs. We'll be plotting straight line graphs and we'll be using inequalities. So we're already familiar when we say x is lesser than, let's say x is lesser than 5. We already know how to represent that. And if we say x is lesser than or equal to 3, we know how to represent that. If we say x is greater than 2, we know how to show that. If we say x is greater than or equal to 7, greater than or equal to 7, we know how to show that. Likewise, if we use y, we also know how to represent this type of inequality on a number line. So we've taken a look at that already. Then if we, for example, if we have, this is our origin 0, and then we say here is probably like 1, 2, 3, 4, 5. Okay, and then similarly we have 1 on the x-axis, we have 2, we have 3, we have 4, we have 5. If we have this as our normal graph, for example, and then if we say show this inequality, x is lesser than 5, so you look for where is the x-axis. This is x-axis. So if you say x is less than 5, it means when we use only less than, we have to use what we call the broken line, the dash line. When we use only less than in inequality, we have to use what we call only the dash line. Dash line is like the one we call the broken lines. So we're not going to use a solid line when we say only less than. When we use only less than in linear programming, so we're going to use this type of dash line or broken line to draw the relationship, to draw the line graph. To draw the line graph, we have to. But when we use this, when we say x is lesser than or equal to 3, then this type of case, we're going to use a solid line. We're going to use a solid line like this. We're going to use a solid straight line like this to draw whatever function we say. Similarly for this, we use broken lines in inequality or linear programming. We use broken lines like this. And if it's greater than or equal to, we use a solid line like this. We use a solid line. So these are another things you need to know about drawing the lines in inequality. For example, if I say x is less than 5, also we have, let's say we have another one, y is lesser than or equal to 2. Y is lesser than or equal to 2, and then we have x plus y is lesser than or equal to 4. Is lesser than or equal to 4. So let's say, for example, let's say we're going to draw for these 3, x is less than or equal to 3, x is lesser than or equal to 3. This, I have this 3 inequality. These inequalities are restrictions that are given to us in practical terms. Let's say they give you a piece of land. They say your garden in your house, a farmer can plant corn in one part of the land, can plant maize, corn in one part of the land, wheat in another part, and any other thing on another part. Now they give you a restriction on how the farmer is going to plant them, the condition or restriction. These conditions and restrictions are called is where you derive your inequality from. They are called the restriction. So restrictions in inequality are what forms your inequality that you use in linear programming. Restriction in linear programming are what forms your inequality. And this inequality is what we graph. We graph our
Sir, you're not share screen.
Oh, okay. Okay. I said in linear programming, I started by saying in linear programming, first of all, we should be familiar with how to graph a normal graph, how to plot a normal graph. So when we have a normal graph, let's say here is -1, -2. Okay, we should have an idea how to plot a normal graph. That's number one. Number one thing we need to know. Then the second thing we need to know, in linear programming is to understand inequality. The second thing we need to know. After knowing how to plot a normal graph, the next thing to know is to understand inequality. So you must have a bit of knowledge on inequality and how to show them in a graph before we start doing linear programming. Then we said in linear programming, can you see?
Yeah.
Okay, we say in linear programming, after understanding the inequality, how to represent inequality, when you say something is less than 5, meaning that it doesn't get to 5. That means that it does not get to 5. Okay, there's a condition, it's a restriction. All inequalities are like restrictions or conditions that is given to you to do anything. For example, if you say the maximum number of players in a football field, it's 11. So maximum is 11, meaning the player can be less than 11 or equal to 11. P is lesser or equal to 11, and the minimum is 7. So when we say maximum, then we say P is lesser than or equal to 11. We use lesser than or equal to when we're talking about maximum. So if you say maximum in inequality, you use lesser than or equal to, because that's how far you can reach. When you say minimum, then you use greater than or equal to. You say P is greater than, or that's the minimum player. That means the player must be greater than or equal to 7. That's the minimum player you have in a football field. So as a combined inequality, we have something like this. So we should know how to show inequality, or if we will give you statements, word problem, we should be able to put them in inequality. Put them because they are usually restriction. We say, for example, if you tell you that a farmer can plant corn on must not be more than 2 corn, then if it's not more than 2, meaning it should be lesser than or equal to 2. If you say corn that the farmer has to plant on the field, it must not be more than 2, that means it should be lesser or equal to 2. And then wheat also, if it must not be greater than 2, we say the wheat he has to plant on his farmland will be lesser than or equal to 2. And if both corn and wheat will take a space of about 10, then we will say C plus W should be lesser or equal to 10. So this will form 3 inequality for us. These restrictions that are given to us will form 3 inequalities. So first of all, we must know how to translate statements into inequality. So I said we can translate statements into inequality by actually understanding that maximum means lesser or equal to. So when we say maximum, we mean lesser. Maximum number of players, we mean it actually represents lesser than or equal to. When we say minimum in English and in inequality to be greater than or equal to. When we say at least, the word at least in linear programming, this word at least represents greater than or equal to. So you minimum, maximum, at least, at most. Then when you hear the word at most, these words, at most, in linear programming, at most, it means lesser than or equal to as well. Just like maximum. At most is just like maximum. You can see both of them. At most is like maximum, it means lesser than or equal to. It means what? Lesser than or equal to. Okay, so at most or maximum, they mean lesser than or equal to. they mean lesser than or equal to. But when we say at least or minimum, they mean greater than or equal to. They both mean greater than or equal to. So these terminologies, you have to get used to them, and then they help us in deriving our inequalities. The moment you derive your inequality, then the rest is to graph them. That's the next step. So the first step is to know how to draw a basic graph, a line graph, a graph. And the next step is to how to identify your restrictions and bring this restriction into inequality. Then after knowing how to put restriction in inequality, the next step to know is how to graph this restriction. So let's say, for example, we say after graphing, the next step to know, before graphing, I explained, I said when they say lesser than, only lesser than, x is less than 5, you use broken line, what we call the dash line. The dash line, dash, D-A-S-S-H. The dash line. Then this is solid line. Okay, when is s is lesser than or equal to, when there is lesser than or equal to, we have to use a continuous solid line. When it is greater than, only greater than, it's also a dash broken line. When it's greater than or equal to, it's also a solid line. So greater than or equal to is a solid line, lesser than or equal to is a solid line. Less than is a dash line or broken line. Greater than is a broken line. So once you know this, the condition for the line, then we are set to graph the inequality. After graphing the inequality, the next number 3 step is, so let's itemize them. The first step is to how to plot a graph, normal plotting of a graph. That's the first step. Number 2 is changing your restriction to inequality. Restriction or condition that is given to you, changing them to inequality. Changing restriction to inequalities. To inequalities. To inequalities. That's number 2. Number 3 is identifying what type of line to use. Types of line to use, whether broken line or dash line or solid line, types of line. Number 4 is graphing your inequality. Graphing. Number 5 is shady. Some they give you conditions also for shady. They tell you leave or shaded the part which satisfy the inequality, or shade the part which satisfy the inequality. So number 5 is shady. Number 6, which is probably the final. Number 6 is identifying the portion that the farmer needs, or the region, the space, the region which represent getting the region that is left after shady. Identifying your region, okay, that is required, region that is required after shady. So these are the 6 things that we need to bear in mind. The first one is knowing how to plot a normal graph, okay, because there are times where you need to have a table like a normal x and y axis, get the values of x and then get the corresponding values of y, okay, so that it will aid you in plotting the line. So this one is very important, putting the graph, having your table putting the graph. Number 2 is to know how to change your restrictions to inequality. Number 3 is the type of line you use. Number 4 is graphing after you know your line, the shady, and then the region. Define the region which satisfy all the inequalities. So now let's take a look at these last 3 we have here. We're going to do 2. The one for this farmer. The farmer, we say he the maximum he can plant 2 in his farm field, and 2 corn, and then the maximum wheat he can plant is also 2. Then corn and wheat, he can have them in there. He can plant 10. So we're going to do this first one, and then we do the second one. Okay, the first one is x is lesser or equal to 3. So lesser or equal to is a solid line. So you go to the x-axis, you come to this x-axis, then you draw a solid line like this. You draw a solid line up like this on 3. Okay, you draw a solid line on 3 like this. Okay, you say x is lesser or equal to, depend on where they want you to shade. If he wants us to shade the region which satisfy the inequality, then we will shade this way. Leave or shaded the region which satisfy the inequality, leave or shaded, then we begin to shade this other side. We begin to shade, because leave or shaded the region which satisfy. X is less than 3 is this way, because less than 3 is on this side, greater than 3 is on this other side. Right? Are you with me?
Yeah.
Okay. Greater than 3 is here. So if the statement say leave or shaded the region, leave unshaded, meaning don't shade that region, shade the other side. Leave unshaded the region which satisfy the inequality, then we're not going to shade that region which satisfy the inequality. We're going to leave it and shade the opposite side. So they say x is less than or equal to 3. Less than or equal to 3 is this way. So the other region, this is the region which satisfy the inequality, so we leave it unshaded, and then we shade the other side. Okay, the part that where x is greater than or equal to 3, we shade that side. Okay, then let's say we have another inequality which says y is less than equal to y is less than or equal to 2. So we go to the y-axis. We come to the y-axis. We draw a line on 2. We draw a line less than or equal to, so it's also going to be a solid line. So it's also going to be a solid line. So y is less than or equal to 2. Y is less than or equal to 2. See, y is less than or equal to 2 is this way. So they say leave unshaded. We're going to leave here unshaded. Right? We're going to leave here unshaded because y is less than or equal to 2. Don't shade the region which is correct. They say leave unshaded. Leave unshaded. So you shade the other side. So I will shade the top. On y-axis, you draw a line on 2. You draw a horizontal line on 2. And then you shade the region where it's greater than 2. But because they say we should leave unshaded the region which is where y is lesser than or equal to 2. The top of the line is where y is greater than 2. But the correct part is where y is less than 2. They say don't shade that part. So I leave it unshaded. I don't shade it. The third inequality that needs to be graphed is x plus y is lesser than or equal to 4. X plus y is lesser than or equal to 4. So whenever you have this type of inequality, what you should do is that you see both x and y, you take them to each other from 4 to 4. On y-axis, you draw a line from 4 down to a line on 4 on x-axis. Okay, but if it's like this, x minus y is lesser than or equal to 4, then the line will be this other side. I would have drawn the line from 4 to 4 this way. Okay, so but if it's x plus y is lesser than or equal to 4, you just draw this line through here to here. Now it's not all the line you can guess like this. In case, I'm doubling the line, which is wrong, which is not, it shouldn't be. Okay, in case you don't know, what should you do? You just plot this, you make y the subject. In case you don't know, make y the subject. You say bring s to this way is less than, assume this is normal equation which is equal to, assumption that this is equal to equation. Okay, this is just an assumption for you to be able to get your table and plot the graph and plot the line graph. So assume that this is equal to, you bring s to this way, become minus x plus 4 plus this 4. This is a normal linear function. Then you get a table. You choose your value of x so that you can get the corresponding value of y. You choose your value of x. I'm just explaining this in case you don't know how to get the line. Okay, there are some cases where you have a linear function where you need to plot the line. You cannot guess the line. So you write x, you write y here. You choose any value for x. You can choose from -2, -3 to positive +3. You can choose. This one is up to you. So you can have -3, -2, -1, 1. Sorry, -1, there's 0, then 1, there 2, and then 3. So this is up to you. You choose the value the way you want, and then you put the value here. So -3, if you put -3 here, here's the equation. X is -3. So minus -3 is already plus. So -3 minus -3 is +3. That's +3 plus 4 becomes 7. So here I get 7. And then -2 is 2. 2 plus 4 becomes 6. -1 is 1. 1 plus 4 is 5. 0 plus 4 is 4. Okay, here we now have 1, right? 1, which makes it -1. -1 plus 4, I get 3. Then I get 2, I get 1. So these are the values I'm going to get. Now you plot this on. If you plot this, you get, you say -3. You go to the negative side of x. -3 to 7. Okay, you trace it to 7. Minus, if we didn't make any mistake, -3 to 7, -2 to 6, then you plot your line. You get your line. Okay, so that's if you don't know how to take the line from one point to another, you plot it and get your line. Now once you get your line, the inequalities say x plus y is lesser than or equal to x plus y is lesser than or equal to 4. So the part that is correct is this way. So I have to shade this up side. I have to shade this side. Okay, this one you tell by choosing a point. Sorry, you tell this one by choosing a point. On this region, you choose a point. Once in inequality, you have a line like this, a slanting line like this or like this. You cannot just tell which way to shade. In order to know the way to shade, you have to, in order to tell the place to shade. Well, let me remove this. Okay. Now, in order to tell the place to shade for this line, since it's a slanting line, you know the one that is easy to tell is the straight line like this or straight line like this. So you can tell which one satisfies the inequality. But this kind of slanting line, you have to do a test. What kind of test are you going to do? We go to test and see if I choose a point on this way. You know, this line has two sides, this way and this way. So I'm going to choose a point here, anywhere you like here, as long as it's this way, this other side. Anywhere you like, you choose a point. That point, you take the coordinate of the values. Let's say I choose here, or let's say I choose this place, where x is 2, y is 1. So you go to slot it into this place and see whether it will be less than 4. X is 2, y is 1. So you say 2 plus 1 is 3. You can see it's less than 4. 3 is lesser than 4. Since it's less than 4, this region, this other side, is the accurate side. This other side is the accurate side. If you test a point here, if you like test here, you will see that this one will not obey the inequality. For example, let's say we choose here. X is 3 and y is 2. Now, if you slot here, x is 3. 3 plus 2, you can see that 3 plus 2 is greater than 4. It's not less than 4. So this way is not the right region. You must test by taking any point below the line this way, this slanting line, By choosing any point below this slanting line, choose any coordinate point, either here, either here, either here. Whatever you're going to get, if you put it into this equation, if you put the values of x and y, the value must be less than 4. If it's less than 4, then this side is the right region. And since they say leave or shade the right region, then we will not shade here. We're going to shade the top. Okay, you know I was already shading it, but I realized I have not explained it. So we're going to shade here because they say we should leave or shaded the region which satisfy the inequality. So we're going to shade this place, right? Is that okay? We're going to shade this place. We're going to shade here. We're going to shade here. Now, if you look, what plot is the farmer going to put his crop? Which land does he have that he has to put his crop? Or which field you have to put your garden? Let's say you want to, in your compound, let's say you have your old compound, you have bought a land, you use linear programming to, you built a house, you use linear programming to know, to calculate which place you should plant flower, which place you should leave, you should tie your compound, and which place you should leave or tie. You use linear programming to do all this calculation in a compound, in a field, which place should be used for flowers, which place should be tied, where vehicle can go in, by first of all giving some restriction and deriving inequality from those restrictions and shades. So the final part, you know, I said there are 6 things that we need to do. Look at that. When you plot the line graphs, you identify your inequality, the types of line. You must know what type of line to use. You graph, we've graphed already. You shade, we've shaded. The part is to identify the region. This region is the part that is remaining, which is this place, which is called the region R. This one. This is the region that we need to do whatever we want to do. This place is the region that we need to do whatever we need to do. So in the exam, if they say identify the region, after giving you some restriction like this, let's say they gave us these 3 restrictions, we graph and we leave this region unshaded. There are some questions they will shade for you, they will do everything for you. They want you to be able to write out the inequality, the 3 inequalities or the 4 inequalities, depends. So it's either they graph for you, they ask you to write out the inequality, or they give you the inequality, they want you to graph it like this. So this is linear programming. This is linear programming. So okay, now we do for this one, the one I said the farmer, this one, the one I said the farmer is going to plant. He has a field, and this field he must not plant. The farmer must not plant the farmer must not plant more than 2 for corn. Maybe 2 plots has to be used for corn, 2 plots has to be used for wheat, and maybe corn and wheat put together in one side, both mixed together. He has to use 10. He has to use 10, maybe 10 plots for his for his field. So we're going to do another linear programming following this question. Let me see.
Sir, this lesson is very hard and confusing.
This question?
This whole lesson.
Oh, okay. You got confused?
I kind of didn't understand. It's.
I give another. Don't worry. One example is never enough.
Can you explain it again? I'm so sorry.
Huh?
Can you explain it again?
Okay. We'll explain it again.
A simpler example. I feel like this whole thing just was too general. I was very confused.
Okay, let me give another example. Can we take a question and we solve another example?
Okay, sure.
But you you understand the conditions I gave, the things you need to get ready in order to do linear programming?
Yeah, I got the things you wrote, but I didn't understand how to solve it, how to what's unshaded, what's shaded, what we're supposed to do, how we're supposed to solve any question.
Okay, don't worry. And let's have another graph, okay? Okay, but before that, let's have this question. Is it on the same pair of axes? This is a question. on the same pair of axes, on the same, I'm not going to like copy everything out, but I read it out. On the same pair of axes, leave unshaded the region which satisfy the following inequalities simultaneously. Okay, question number 2. Do you want me to write it out? No, right? I just need to write the inequality. On the same pair of axes, just listen to the instruction. On the same pair of axes, leave unshaded, meaning don't shade the correct region. Leave unshaded the regions which satisfy the following inequalities simultaneously. Now, these are the inequalities, which we also call the restrictions. We say x is lesser than or equal to 2. This is the first inequality. The second inequality is y is greater than negative 1, is greater than negative 1. Then the third inequality is y is lesser than or equal to negative 3. Sorry, is lesser than or equal to 3. And then the fourth one, here they're giving us 4 inequalities. The fourth one is y is lesser than or equal to x plus 2. Y is lesser than or equal to x plus 2. So these are 4 inequalities. They want us to graph this. The question is, again, the question is, on the same pair of axes, leave unshaded the regions which satisfy the following inequalities simultaneously. So the regions, we should leave unshaded the regions which satisfy the following inequalities simultaneously. So the first thing we do is to sketch our graph. The first thing we do is to always sketch our graph, right? So we have our graph. We sketch our graph. Okay, here we have just a minute, trying to plug my computer. Here you have your x-axis. Here you have your x-axis. Here you have your y-axis, right? Now let's begin to here is 0. Let's say here is 2. Here is 4. Here is 6. So I'm using 2, 2. Here is negative 2. Here is negative 4. And here is negative 6. Okay, for the x-axis, we have, let's say 1, 2, 3, 4, and so on and so forth, 5. Here is negative 1, negative 2, negative 2. You can choose scale the way you want. Negative 3, negative 4. Okay, let's say we have this. Let's say this is our graph. Now let's begin to put each of the inequality in the graph. Remember I said when you have lesser than or equal to, you must use a solid line. Do you remember that? Hello?
Yeah.
Yeah, when we say lesser than or equal to, we use a solid line. So you go to x-axis. S is lesser than or equal to 2. Lesser than or equal to 2. X-axis, x is lesser than or equal to 2. So I'm going to draw a line to pass through 2 on x-axis. Is that okay?
Yeah.
A solid line. We're going to draw a solid line to pass through 2 on x-axis. A solid line to pass through for this first inequality. Okay, and they said we should leave unshaded. X is lesser than 2 is this way. Am I right? This way. Lesser than 2 is the way going to 0 side. This way. Greater than 2 is here. So leave unshaded the region which satisfies the inequality. So don't shade here. You say on the pair of axes, leave unshaded the regions which satisfy the following inequality. So we will not shade here. We shade the opposite side this way, where is greater than 2. Did you get that?
Yeah.
So we go to shade. We are following the instruction of the question. It says leave unshaded the region which satisfies the inequality. So x is less than 2 is this way. Lesser or equal to 2 is this way. 2 or less than 2 is this way. Greater than 2 is this way. So we shade the greater side, that side, because they say we should leave unshaded the region which satisfies the inequality. Lesser than 2 is this way, which because they say x is lesser than 2, we're not going to shade that part. They say we should leave it unshaded. But that does not mean you will not shade, because linear programming is about shading some regions and leaving some regions unshaded. So we go to shade this way. We go to shade this side. Okay, we shade this way and leave the other side unshaded. That's the first step. So every inequality we take, we do this to it. Now look at this one. Y is greater than -1. We're going to use broken line. Why? Because this is just only greater than. It's not greater than or equal to. So we're going to use broken line for this y. Are you with me? So I'm going to use broken line. So let me select another color for it, probably, to make it conspicuous. So y is greater than -y. Y is greater than -1. So -1 is somewhere here. -1 on the y-axis. -1 is here on the y-axis. So we say y is lesser than this. And sorry, y is greater than -1. So the region which I will use broken line to draw the line pass through -1. To pass through -1. Okay, in your normal graph, use pencil and a ruler to do this so that you can get a very straight line. Okay, in our case now we're sketchy, so it's excusable. Now, where is y greater than -1? Greater than -1 is up, right? Is the up part. Am I right? This up this way. Greater than -1 on the y-axis. Are you with me?
Yeah.
Do you know how why we draw this broken line on -1 here? Because of this inequality, because of this one. It says y is greater than -1. So you go to -1 on the y-axis, you draw broken line on it. A straight broken line on it. Do you get that?
Yeah, not really, but
I said every inequality, you go to the graph and draw a line. Simple, that's what I said. Every inequality they gave to you. This one, they say x was less than 2. We went to x-axis. Where is x-axis? Horizontal axis is the x-axis. We draw, and I said, if it's lesser than or equal to, you use a solid straight line. That's why we go to x-axis. On 2, you draw a line down through to pass through 2. That's how we did this. And then you now follow the rules. Since it's a less than 2, they say don't shade the lesser than. Any part that is less than 2, don't shade it, shade the opposite side. That's how we did this, which you said you understood. Now for this second one, y is greater than -1. Go to y-axis. This is the y-axis. Where is -1 on the y-axis? This place. Draw a line across that -1. Draw a broken line. Why? Why are we using broken line? Because it's only greater than. It's not greater than or equal to. So because it's only greater than, you go to use a broken line to draw a line across -1. Across this -1 on the y-axis. Across -1 on the y-axis. In other words, we're just following what is here. The inequality that they've given to us. Did you get that?
Yeah.
Okay. Now, to know where to shade, after knowing the line, the type of line to draw and where to draw the line, the next is to know where to shade. Now, how do you know where to shade? They say y is greater than -1. Greater than means up. Since we are talking on the y-axis, the greater than means the greater than 1 is up on top of -1. on the y-axis. On top is the greater than. Am I right? The greater than 1, the greater than minus 1 is anything above this negative 1. Am I right?
Yeah.
And the question say leave unshaded. Don't shade that correct side. They say you shade the opposite, meaning we're going to shade the down part. Because they say, because it depends on the question. Some question will say shade the region which satisfy the inequality. If they say shade the region, we would have shaded this place. However, this particular question said leave unshaded. Leave unshaded. Don't shade that region which satisfy that inequality. So since the region which satisfy this inequality is up this way, the place that is greater than negative 1 is up this way, we will not shade that part. Because that's what the instruction said. It said leave unshaded. Meaning don't shade that region which is correct. Shade the other side which is not correct. That's the meaning of that statement. Leave unshaded the region which satisfies the inequality. So this place is the part that is correct because greater than negative 1 is here. It's up this way. Everything up this way. So we shade the bottom part. We shade the lower part of negative 1. We shade the lower part of it. Okay, we shade all this bottom part of negative 1. You shade nicely with your pencil and make it nice. Okay, now you go choco like mine. Make it nice like this. Shade every region below the line. Shade this region. So we've done the first one and we've done the second one. We've graphed and shaded the first two inequality. Now it's time to do the third one. The third one is still also y. It's still y. So since it's y, what we need to do is simply to come to the y-axis and look for 3. 3 is here. 3 is here, this place. Between 2 and 4. 3 is here. So we're going to draw a solid line. Why a solid line? Because, excuse me, because it's lesser than or equal to. Once it's lesser than or equal to, you draw a solid line across 3. You draw a solid line across 3. A solid line like this across 3 on the y-axis. Across 3 on the y-axis. Is that okay? Because we are describing y. Because we are describing y. Are you with me?
Yes.
Okay. So, and then it say y is lesser than or equal to 3. So lesser than is at the bottom this way. Lesser than. Where y will be lesser than 3 is down part, below 3. That's where the inequality is correct. You say y is lesser than or equal to 3. So the correct region is below 3. And the question says leave unshaded. Don't shade the correct region. Shade the opposite side. So I'm going to shade the top of it. I'm going to shade the top of this one. We're going to shade the top this way. Because they say we should leave unshaded the correct region. Don't shade the correct one. Shade the opposite one. Is that okay? Are you with me? Linear programming is actually super easy. You just need to follow. Is that okay?
Okay, can you do more questions?
Yeah, when we finish this one, and then we will do another one. Okay, we will do. Don't worry. Till you're good with it. Till you feel good about it.
Okay.
Okay, so now we are left with the fourth line. We're left this type of line that has x and y combined together. The best way for you is to plot the graph. The best way is to plot the graph. How? It's just to assume this is equal to. It's like you have y equal to, for example. It's just an assumption, okay? Assumption in the sense that so that you can easily plot your graph. If you have y equal to x plus 2. Let's say this is what you have, and then you make a table so that you can get your table of values, and then you plot the point, and then you get your straight line graph on this graph. Because you may not be able to sketch it accurately if you don't plot it. Whenever you have x and y together, like equation of a straight line, you remember x and y together, a linear function like this, it's better to plot the graph. It's better to plot the graph so that you can get the accurate line graph. So I have x here. I have x. I have x here. and then I have y here. So you choose values for your x. Okay, maybe we not take too many values. We say -2, -1, 0, 1. You choose any value you like, okay? 1, this one, not -1, and then 2. It's up to you. You can choose from 2 to 5. You can choose from 0 to 5. It's up to you, okay? There's no cause for alarm. Then 3. Let's say 3. We're choosing from -2 to +3. Okay, so you just put the value here and get the corresponding value of y. So if x is -2, if you put -2 here, -2 plus 2, y will be 0. -2 plus 2, y will be 0. Do you know how I got that? You know how I got this 0 for y?
How?
I see. You choose. I say choose any value for x. You know, you make a table. You know, normal how when we are plotting graph, we just make a table. You choose any value for x. In my case, I choose -2 to +3. -2, -1, 0, 1, 2, 3. These are the values I choose for x. So what I should do for y is take this value of x, put in this place of x, and get what you get for y. So if I take -2, put here, -2 plus this 2, -2 plus 2 becomes 0. That's how I got 0 for y. Did you get that now? Like this. You say y equal to, you say x is -2, this box. X is -2 at this box. So I put, instead of writing x here, I put -2 there. So I say -2 plus 2. -2 plus this 2 in the equation, plus this 2 in the equation. You know, this is like equation of a straight line. Remember equation of a straight line, y equal to ms plus c. Okay, y equal to mx plus c. Okay, this m is 1. You know, in math, x has a coefficient of 1. We don't write. This gradient, m is 1, c is 2. The y-intercept is 2. Okay, so I'm just comparing them. They're similar. So what we should do is to put the value of whatever value you have for x, put it in this place, and see what you will get for y. So if you take this -2 here, put it in place of this x, we have my x is now -2 there, plus the 2, which is this 2 already in the equation. So -2 plus 2 is 0. That's how we got 0 here. You do the same for this one. You say in place of x, you put -1 here. X is -1, put it here, and then we have y will be what? In the second case, y will be, are you paying attention?
Yes, but I'm still confused.
You have to open your mind. I'm showing it step by step. I'm not showing it like, I'm not fast in doing this. So open your mind. This is, you cannot be confused in plotting graph. You've done how to plot graph quite a number of times. So I'm just plotting a normal graph of y equal to x plus 2. And then I say choose anything you like for x. Choose the value of x the way you liked earlier. Choose 1, 2, 3, 4, 5. If you choose 1, 2, 3, 4, 5 for x, and then every box replace the value of x with x here. And then you add these two to whatever you put here, add these two to it, you get the value of y. We just want to fill up this table, and then we can plot this line graph. Is that okay?
Yes.
Okay, so here x is -1. I'm going to, in place of x, look at the function is y equal to x plus 2. This is the function. Y equal to x plus 2. This is the function, right? This is the function. Y equal to x plus 2. So now I want to replace x with -1. So if I replace x with -1, we have -1 plus this 2. -1 plus 2. -1 plus 2 is what? Is equal to 1. Right? -1 plus 2 is 1. So I have 1 here. Then I do the same for this to find y here. To find my y here, I replace x value with 0. So I come here, I say my y will be equal to the value of x is 0. This box, the value of x here is 0. You use 0 to replace the value of x here, then you say plus 2. 0 plus 2, your answer will be 2. Your answer will be 2. So that's how we got 2 here. So we put the 2 here in order 0. Then here x is 1. X is 1 here. So what we should do, in place of x, put 1 here. Y will be 1 plus 2. Y will be equal to 1 plus, in the place of x, x is 1, right? And then you say 1 plus 2. We are using this same equation for all. We're using this same equation for every location in the box. So we say 1 plus 2, and then we get 3. 1 plus 2 is equal to 3. So I write 3 here. I write 3 in this place. Then for this place, x is 2. What I will get, 2 plus 2, because x is 2, I will say 2 plus 2, I will get 4. That's how I get 4 here. For this last place, x is 3. So I'll come here. If x is 3, I will say this 3 plus 2, I will get 5. That's how I got 5 for y here. Are you with me? Are you with me?
Yeah.
Okay. The next thing to do, once you get this your table, you know what we are doing? The last inequality, this inequality, what I'm doing, I'm trying to draw the line graph. Because if you sketch, you might be wrong. It's not like y equal to this, or y equal to this, or x equal to this. The one that has only one variable, x, is easy to draw. The one that has only one variable, y, is easy to draw the line graph. But the one that has both x and y together, you make a table and plot it and get your normal graphs. Then you will now know, we will test after doing that, and we know where to shade, where not to shade by testing. Now, let's plot. Go to your x-axis, -2 on your x-axis. Look at my table. The first value for x is -2. So -2, I'm going to trace it to 0 on y-axis. -2 to 0 on y-axis. So y-axis is this one. So -2 to 0 is this same spot. I'm going to mark it. Is this same spot. -2 on x-axis, trace to 0 on y-axis, is this same spot. So we mark it. The next one is -1 on x-axis, trace it to 1 on y-axis. -1, trace it to 1. Remember, 1 is here. Remember. -1, trace it to 1, then is exactly this spot. Right? -1 on x-axis, look at it. -1 on x-axis, trace it to 1 on y-axis. Look at it. If you want to do tracing, see. If you want to do tracing, you will see it. You will see something like this. Okay? But I feel you already know this. So -1 on x-axis, trace it to 1 on y-axis. Then you put your mark there. You mark it. You put your point there. Then -0 on your x-axis, trace it to 2 on y-axis. 0 on x-axis, this place, trace it to 2, which is here. Then 1 on x-axis, trace it to 3. 1 on x-axis, trace it to 3 on y-axis, which is here. And then 2 on x-axis, trace it to 4. 2 on x-axis, trace it to 4 on y-axis. See, 2 here on x-axis, look at 4 on y-axis. So where they meet, you mark it. Where the 2 points meet, coordinate point, you mark it. Then 3 on x-axis, trace it to 5 on y-axis. 3 on x-axis, trace it to 5 on y-axis. Remember, 5 is here. Halfway between 4 and 6. Here is 4, here is 6. Halfway between 4 and 6. So trace 3 to 5. Trace 3 to 5 here. So I mark this place. Now you see my point. The next thing to do, since the equation is lesser than or equal to, I'm going to use a solid line to join them, not broken line. Since the inequality is lesser than or equal to, if it's only less than, I would have used broken lines to join all the points. Since it's lesser than or equal to, I'm going to use a solid line to join all my points as a straight line. Okay, if you do this in a graph paper, it will be super smooth and super nice, and it's a straight line graph. See, we get our line graph. Okay, we get our line graph. Now the next thing to do is to know where to shade. After you get your line graph, is to test where to shade. I said because it's a slanting line, you don't know whether greater than or lesser than is at the bottom. You don't know where to shade. Anytime you have a slanting line like this or like this, you have to do what they call test to see whether it obeys the inequality, right? Whether it obeys the inequality. So if you look at it, if you bring your x to this side, you have y minus x. Y minus x is lesser than or equal to 2. See, this is same as this, okay? The only thing I did, I brought x here. Become minus x. This is exactly same as this one. Same. Okay, so to test, let's say I choose any point I like below this slanting line, below this slope line that we've gotten. We choose any point. Let's say I choose here first. If it's not correct, then I can choose any point above the slanting line, the slope. I can choose any point above the slope, but I want to choose a point below to know whether that's the right part of the inequality. So I choose here. Here, x is 1 and y is 2. See, look at this coordinate point that I chose. X is 1 and y is 2. So you feel it here. 2 minus 1 is actually less than 2. It's actually less than 2. 2 minus 1 is 1. So 1 is less than 2. So this is the correct region. Once it obeys this inequality, then it's the right region. So I will not shade. Remember, they say we should not shade the right region. So I'm going to shade the top. I'm going to shade the top part because they say we should not shade. We should leave unshaded the right region. So we shade the opposite part of the slanting line. We shade the opposite part of the slanting line. Then the remaining region that is never shaded in your work, the remaining region that is not shaded, which is this, is your region that is required. Your arrow, your region that is required. Are you with me?
Yes, I understand a bit, but
okay,
still not that clear.
Okay, no problem. No problem. I think we still have to take another problem and then we see how. Right?
Yes.
We take one problem and then we see how. Now let's question number 3. Question number 3. We said this one is a long sentence. It's in West. Okay, I think we should look for simpler one first. It's in West, and maybe I should simplify it. Maybe we should simplify it in. Let's simplify this one. It's in West. It said the number of field a farmer plants with wheat is W. The number of field a farmer plants with wheat, you know, wheat, WHEAT, wheat. Okay, the number of field a farmer plant with wheat is W, and the number of field he plants with corn is C. So wheat is W, corn, CORN, corn is C. So wheat is W, corn is C. Okay, he said the number of field a farmer plants with wheat is W, and the number of field he plants with corn is C. There are, however, certain restrictions which govern how many fields he can plant of each. These are as follows. Now they've given us some restriction or conditions, and this restriction will form our inequality. Every singular one I read out, we draft the inequality out, okay, once and for all. He said there must be at least 2 feet of corn. There must be at least 2 feet of corn. At least means there must be at least 2 fields of corn. At least means must be greater than or equal to 2. So you said C must be greater than or equal to. C, since he said there must be at least 2 fields of corn, you say C is greater than or equal to 2. Remember, I wrote these things out today. At least means greater than or equal to. At least. Sorry, there's S here. At least means greater than or equal to. So since it says there must be at least 2 fields of corn, meaning corn must be greater than or equal to 2. Meaning it can go above 2. The minimum is 2. The word at least means minimum is 2. So corn can be equal to 2 or greater than 2. At least 2. Okay, that's that for that. Then the second restriction, because we have to itemize the restriction and bring out our inequalities from the restrictions. The second restriction is that there must be at least 2 fields of wheat. There must be at least 2 fields of wheat. So wheat is greater than or equal to 2 as well. There must be at least 2 fields of wheat. So wheat must be greater than or equal to 2. That's the second restriction, and which forms our second inequality. The third restriction, which will form our third inequality, after we get this, then we graph, is that not more than 10 fields are to be sown with wheat or corn. Not more than 10, meaning must be lesser than. He says it should not be more than. Not more than 10 fields are to be sown with wheat or corn. So I will say W plus or C plus W must be lesser than or equal to 10. C plus W must be lesser than or equal to 10. So these are my 3 inequality, but they will not give you like this in some questions. In some questions, they will give you the word problem. You have to change this word problem to inequality, and then you graph. You change them to inequality just like we have, and then you graph. Now here comes the main instruction. It says construct the 3 inequalities. First of all, you have to construct the 3 inequalities from the information that they've given us. So we've done the first part of the question. They want us to obtain the 3 inequalities from what they've told us with words. So we've done that. They say we should construct the inequality. We've done that. The second part of the question probably is to graph. You say on one pair of axes, the second part of the question, the B. The B part of the question says, on one pair of axes, graph the 3 inequalities and leave unshaded the region which satisfy all 3 simultaneously. Graph the 3 on the one pair of axes. That means draw only one graph. On one pair of axes, graph the 3 inequalities and leave unshaded the region which satisfy all 3 inequalities. That's the B. So we go to graph them. The C is give one possible arrangement as to how the farmer should plant his field. One possible arrangement as to how the farmer should plant his field. But before we do that, we have to graph these 3 inequalities. We have to graph these 3 inequalities. So what then should we do? What we should do is to simply just have our normal line graph, right? Our normal graph. We have our y-axis, and then we have our x-axis. So we can call here our width. The y-axis can be our width, and the x-axis can be the cone. Are you with me?
Yes.
Okay. So now let's begin to, here is 0. Here we can call 2. Here 3. Here 4. Here 6. Every box 2 units. Here 8. And here 10. Similarly, we do same here. Here 2. There are no negative number in this inequality, so everything will be on this side. There you can see, right? I guess there are no negative number. So here is 2, here is 4, here is 6, here is 8, and here is 10. So now we begin to graph. The first inequality is that C is greater than or equal to 2. You go to C axis, this C axis. Go to where 2 is. Because it's greater than or equal to, I'm going to use a solid line. Let's change the line. I'm going to use a solid line because, why? Because it's a greater than or equal to. Whether greater than or equal to or lesser than or equal to, as long as there is also equal to part of it, then you're going to use a solid line to pass through 2 on the cone axis. On the core axis, go to 2, draw a solid line across 2 on cone axis. Is that okay? Do you get that?
Yeah.
Okay. Then let's shade. It says C is greater than or equal to 2. Greater than or equal to 2 is this side. Greater than 2 is this way, this other side, right? But the question says we should leave unshaded the correct side. On a pair of axes, graph the 3 inequality and leave unshaded the region which satisfies the 3 equalities. So greater than is this way, greater than 2, the cone greater than 2 is this other side. Anything above this way, all this region is greater than 2 for this cone axis. So we say we should leave that side unshaded. So I'm going to shade this, all this other side. I'm going to shade all this other side. The opposite side. Are you with me?
Yeah.
Okay. Are you paying attention?
I am.
Okay, great. So we shade this side. Then we draw the second one for W. W is greater than or equal to 2. Go to the W line. It's also, since it's greater than or equal to, I'm also going to use a solid line. So we choose a different color for this. We on W axis, draw a line across 2. A solid line across 2. On W axis, which you call the Y axis, draw a solid line across 2. Draw a solid line across 2. After you've done that, the next is to understand your inequality. Where to shade, the shady part. You say W is greater than or equal to 2. Greater than 2, it's anything above this whole line. That's the greater than 2. So don't shade the above, because it's a leave unshaded. Leave unshaded. W is greater than or equal to 2. Where is greater than 2 is this way. So shade the lesser than, shade the opposite. Shade the opposite. Don't shade the greater side of line of cone. Are you with me? Do you know why I'm shading?
Yes.
Do you know why I'm shading this way? You know why we are shading this way? Okay, we are shading because the rule say we should leave unshaded the correct region. meaning don't shade the correct region, shade the opposite side of the region. Okay, when you say W is greater than 2, the W as this is this one, right? You drew a line across it. Greater than 2 is anything above the 2, above this 2. Above this line you drew, right? Anything above this line that we have drawn is what is greater than 2. So it's a leave anything, the correct region, don't shade it. Greater than 2 is the correct region, this way. So don't shade this way, shade the opposite, the below the line. Are you with me?
Yes.
Okay. Then for this one, C plus W equal to 10. When you have C plus W equal to 10, it's almost same like this C. Like if you move W to this side like a linear graph, this will be minus W plus 10. So you can see this one has a negative gradient. Assuming C is your Y. Okay, sorry. Let's say, we already assumed W to be our Y. So if you have C plus W is lesser than or equal to 10, W is like your Y. If you make your Y the subject, like you want to get a linear graph, will be lesser than or equal to, you move C this way, it becomes minus C plus 10. This is same, sorry, where I wrote Y here is W. Okay, W is assumed to be your Y-axis, because W is what you put on your Y-axis, and your C is what is on your X-axis. So if you look at this, there is a negative gradient. This X, C is representing X. So it's negative. So when you have this, whenever you have this, we're going to draw a straight line from 10. Both of them will be taken to 10. C and W will be taken to 10. I'll go to 10 on W. I'll draw it to 10 on C. I'll draw the line. This one, if you don't know, then you plot. You know the plotting we did when we make a table. You choose value for C and get the corresponding value for W, and then you will be able to draw this line graph. But sometimes we already know them. When you are very familiar with it, you already know where the line is going, because you can see it's a negative gradient. And you go to draw it between W and C, you go to draw from 10 to 10. So negative gradient means it's going to slope down this way, like this. So you just draw it. You don't have to make the table and plot. Now, the only thing we need to do is to test. Choose any point on this way and choose a point on this way. First, if you choose a point here, if it's correct point, no need to test the other side. Then you know where to shade and where not to shade. Now, let's choose any point. Tell me where to choose this way of this line. This line, the slope, I want to choose a point on anywhere here. Can you tell me where you want me to choose? Anywhere on this side. Hello?
I couldn't hear your question.
Okay, we see. Every line we draw, we must shade the unwanted region and leave the wanted region. The wanted region, we leave it. We shade the unwanted region, because they say leave or shaded the wanted region. So for this sloping line or this type of slope, you have to find out which part is the correct part by choosing any point on this side of the line or on this side of the line to see which one will be equivalent to C plus W lesser than or equal to 10. Any part of this region that will fulfill this inequality. So for example, I say you can choose any part. For me, let's choose this place. If I choose a point here, you can choose a point here. As long as it's on this way, this whole side, it's okay. You can choose a point here, you can choose a point here. As long as it doesn't touch the line and it's on this side of the line, you can choose a point. So if every point you choose, you look for the coordinate. The C value is 4. Trace it down. C value is 4. W value is also 4. So I will say 4 plus 4. You can see 4 plus 4 is less than 10. So this is the correct region. So don't shade the correct region. If, for example, okay, let me choose the wrong side. Let's say we choose here. Let's say I choose this point. Now the c value is 8, and the w value is 8. 8 plus 8, you can see, is 16. 8 plus 8 is 16. Is 16 less than 10? No. 16 is not less than 10. So this way cannot be the correct region. Even if, not because I took it farther away, even if we choose this place closer to it, even if I choose a point closer to it, we will still not get the correct, this side will not still be the correct side. Why? Because the value we will get here on this way will be greater than 10. And it shows that this way is not the correct region. To know the correct region, you have to see that the value less than 10, whatever C and W is, must be less than 10. So here C is 6, and W is 6. 6 plus 6 is 12, is greater, is not less than 10. So this region is the wrong region. This side is the correct region. Do you get that? Now once you get the correct region, it says leave unshaded the correct region. So we have to shade the unwanted region. We have to shade the unwanted region. So I can shade this up part because it's the unwanted, is the wrong region. Shade that wrong region and leave unshaded the correct region. This way is the correct region. So I'm not going to shade this way of the line. So I'm going to shade this way, this side of the line. That's what we're going to shade. You shade this place. So you can see the region the farmer has to plant is this arrow, is this whole place, this whole place. That looks like a triangle. This triangular space is the region the farmer has to plant whatever he needs to plant. The C part of the question says, give one possible arrangement as to how the farmer should plant his corn. Okay, you can see when we choose this point, we got 4 feet of corn and 4 feet of wheat. So the farmer can plant 4 fields for corn and 4 fields for wheat. Okay? Or the farmer can plant 6. If you choose here, the farmer can plant 6 feet of corn and 4 for wheat. So that's that for that. Do you understand this?
Yes.
Okay. So we can try graphing. Anyone? Do you want me to give you anyone to try? Or you still want me to? Huh?
Can you do more?
Oh, okay. Okay. Have y is lesser than or equal to 4, x plus 4. Y is lesser than or equal to x plus 4. Gradient is 1. See here, gradient is 1. If you check this line, if you calculate the gradient of this line, you see it's equal to 1. Right? The gradient of this line is 1. How? 10 minus 0 is 10. Then over 6 minus 4. Minus 4 is plus 4. It becomes 6 plus 4, which is 10. So 10 divided by 10, you get a gradient of 1. So this line is the line that represents this inequality. This inequality is represented by this line. So we shade. To know where to shade, you have to test either below the line or above the line, which region satisfy the inequality. Let's say I choose a point here, 2 and 4, 2 for x, 4 for y. Now, y is 4 and x is 2. You can see 4 will be less than, this 2 plus 4 will be 6. 4 for y is less than 6. So this region is the correct region. So don't shade this side of this line. Shade this upside of this line. You shade the upside. And then for this one, x plus 2y is lesser than or equal to 80 is this line. it will reach 80 for x, and it will go to 9 for y. It will pass 2.9 for y. So you also test which part is the correct region. For example, if I choose this point, x is you can choose any point, okay, not necessarily where we've chosen. If I choose this point here, x is 8 and y is 4. So 8, y is 4. 2 times 4 is 8. 8 plus 8 is 16. You can see 16 is less than 80, is lesser than 18. So this is the correct region for this line. So you don't shade it, you shade the up part. At the end of the day, you see this whole place will remain. This whole place will remain. This place, only this place will remain as the region, the wanted region. Is that okay? So maybe we can graph. Do you want us to graph this equation, this one?
Sure. Yeah.
Okay, let's graph this one and write this inequality out. Okay, sometimes my lines are not very straight. And then we have here's 0. Here I have 2. Let's use 2, 2. 4, 6, 8, 10, 12, 14, 16, 18, and 20 for x-axis. For y-axis, we can have same thing, 2, 4, 6, 8, 10, 12, and so on and so forth. Okay, then here we have negative 2, negative 4, negative 6, negative 8. And then here we have negative 2, negative 4, negative 6. Okay, let's say this is our graph. We have a line passes through 4. We have a line passing from negative 4 pass through 4 and upward. So we have a line passing through negative 4 from negative 4 passing through 4. Okay, here we have one line, and then we have another line from 6 to 6. Let's use a different color. From 6 we have another line 6 to 6, and then we have another line. Okay, but 6 passes through 6, and then 9 to 18. Then we have a line on 2. Okay, so we have a line on 2. We have a line on 2. Then we have a line from 9 to 18. We have a line from 9 to 18. Okay, these are all the lines, and these are the inequalities given to us. Y is greater than or equal to, these are all the inequality. Y is greater than or equal to 2. And then we have another inequality where x plus y is 6, x plus y is 6, x plus y is less or equal to 6. Then we have another one, y. We have another one, y is lesser than, okay, this is greater than or equal to 6. Y is lesser than or equal to x plus 4. Y is lesser than or equal to x plus 4. And then we have the last one, which is x plus 2y is lesser than 18. X plus 2y is lesser than or equal to 18. So these are the 4 inequality, 1, 2, 3, 4. But the good news is that you're not drawing, they've drawn all the line for you. This one is greater than, this one is greater than or equal to 6. So, like we said, first and foremost, the first thing you do, you test. This one that has only y is greater than 2, you don't need to test. Greater than 2, you know it's on top above the line of 2. Greater than 2 on the y-axis, here is the y-axis, and here is the x-axis, okay? So greater than 2 is the region that is above 2. It's a leave unshaded, right? That was the instruction. Let's see the instruction again. It said by shading your wanted. So you shade your wanted. Leave unshaded the region which satisfy the inequality. So we shade your wanted region. So for this one, greater than 2 is above this place. So we shade the below part. We shade the below part. So we're going to shade this one, the below side of this 2. Any region below 2. Because the inequality is y is greater than or equal to 2. That's the correct part. So you say shade your wanted region. This is your wanted. The region above 2 or greater than 2 is the wanted region. So we shade the below region for this inequality. This inequality is for y is greater than or equal to 2. This one, for this line. Every line we write the inequality next to it. This one is y. Y is lesser than or equal to x plus 4. X plus 4. This one is x plus y is greater than 6. This one. The line goes up, okay, continues. And also go down. This one is x plus y is greater than or equal to 6. And then this one is x plus 2y is lesser than or equal to 18. It's lesser than or equal. So these are the inequality. We've identified each of the line, we've put their corresponding inequality beside them. The next thing to do is to shade. Now we shaded this first one, so we can circle the one we shaded. We shaded this one, so we're done with it. So we have to shade this one. X plus y is greater than 6. Now this one. So I said to know where to shade, you can test on this side of the line or on this side of the line. So we see whether it will be greater than 6. And we say greater than 6 is this way because, for example, let's say I choose a point here. I choose a point here. The coordinate of that point is 6 for x and 4 for y. 6 for x and 4 for y. So if you come here, x is 6, y is 4. You can see 4 plus 6 is greater than 6. It's greater than, we're supposed to get either something greater than 6 or something that is at least equal to 6. So you can see 4 plus 6 is 10. 10 is greater than 6. So it means this way is the correct region of this line. For this line, anything above this way is the correct region. Anything below this way is the unwanted region. So we shade the unwanted region. We shade the entire unwanted region. We shade this way. We shade. Are you with me?
Yes.
Okay. Okay. Now we test for this one. Which way is the wanted region? Okay. Let's do this one. Let's test for this one first. Let's see which way is the wanted region and which way is the unwanted region. Okay, for this one, if I test this same point, because this point is on this side, this same point is on this side, or let's test this point here, a point here. Let's test a point here, and the coordinate of that point is 4 for x, if you trace it, and 6 for y. 4 for x, 4 for x, and 6 for y. So here you have x plus 4, so x plus 4 plus 4 is 8. Is 6 not less than 8? 6 is less than 8. It must be lesser than or equal to, at least equal to 8, but it's less than. So which means this is the correct region, because 6 is less than 8. So this is the correct region. So don't shade this side. Shade this other side. You shade this other side. Is that okay?
Yeah.
Okay. Now for this one, I think this is the only one remaining that we've not shaded for. For this one, we test, okay, the wanted region. If we test here, let's say here, whether here is the wanted region, we test here. If you see here, x is 10 and y is 6. X is 10, y is 6, plus 2 times 6, y is 6. 2 times 6 is 12. So if you add 12 plus 10 is 22. 22 is not less than 80. You can see 22 is greater than 80. So this is not the right region. This is the right region. Let's test a point here now to see. You take a point here. You see the x value is 8 and the y value is 4. X value is 8, y value is 4. X value is 8, y value is 4. So since y is 4, 2 times 4, we will get 8. 2 times 4, we get 8. So 8 plus 8 is 16. You can see 16 is less than 18. 16 is less than 18, lesser than, at least equal to. So 16 is less than 18. So this is the correct region, this way. And this way is your wanted region. So I'm shading the top because it's your wanted region. It's not the right region for the inequality. So I'm shading this up part. So at the end of the day, the region they have to do whatever they want to do, the question needs to do whatever they want to, is this entire region. This region. See, all here, all here, all here, all here is the region, the required region. This is the required region. Okay, that this question wants from us. So if you look at it here, they don't have. See, they put arrow in this region, meaning this is the required region. They don't have shady techniques, so they just tell you where that region is in this region. Is that okay? Do you get it?
Yeah.
Okay, this is our question number 4. Now let's take another question. Oh, our time is over. Hello?
Yeah.
I say our time is over.
Oh,
It's 8:33. But let's see a question, even if it's an explanation.
do we have a class tomorrow?
Yes.
We have 2, right?
Yes.
We still have rearranging formulas and area, but I guess I'll try to do them on my own, and if I have any question, I'll ask you.
Okay. Okay. Okay, so can we go through this one? It's not like we're not going to like it, this one is already shaded for us. Or we close for today.
Um, just one more question.
Okay. Take a look at this one. They've shaded it for you. This is the region, right? They've shaded everything. This is the required region, then everything. So they're saying, the question says, find the three inequality which defines the shaded region on the grid. Three inequality which defines the shaded region. I've seen one inequality. Every line has its own inequality. Okay, there is one inequality here. See this one that passes through here. It passes through the x-axis. So x is greater than or lesser than or equal to 0. No, x is greater than or equal to 0 because they shade anything above the 0, anything greater than 0. S is greater than or equal to 0 because it's a solid line. This one inequality. So our first inequality for this is our first inequality is question number 5. Our first inequality is x is greater than or equal to 0. Why? Why is an inequality x greater than or equal to 0? See, our first inequality is coming from this 0 line. This solid line passes through the 0 axis on the x-axis. You know, this x-axis, this straight line on the x-axis, we draw a line across the 0, which form the y-axis. The y-axis line is actually an inequality line for this question. Okay, and because the region that is required is greater than the 0, the region is greater, so you say x is greater than or equal to 0. That's the first region. Is that okay? Why we use greater than or equal to? Because it's a solid line. If it was a broken line, we would have just say s is greater than 0. That would have been the first equality. But the first inequality is s is greater than or equal to 0. Is that okay? Are you with me?
Yeah.
Okay. Let's see this one. You can see we can find the gradient of this line and know which line this inequality will be. Okay. The gradient is 2 minus 0 over 4 minus 0. So imagine I'm looking for the gradient of this line. So 2 over 4 is 1 all over 2. So 1 all over 2 and it passes through 0. Passes through the intercept on y-axis is 0. So half x. Y equal to half x. And y is okay, we see whether it's lesser than or equal to that we use by testing any point. Right? Y, if you want to know whether this is the required region, if I put a point here, okay, y is greater than or equal to 0, greater than or equal to x, half x. Y is greater than or equal to half x. That would be the second one. Let me see. That would be the second one. Y is greater than or equal to half x. How do I know that? How do we know that it's half x?
How do you get fractions? I don't get it.
Because I look for the gradient of this line, the gradient. You know, we normally use the equation of a straight line. Remember, y equal to mx plus c. Y equal to ms plus c. C is 0. Why is c 0? This c is already 0. So we're not going to count it. Why? Because this line passes through the 0 axis. It does not pass through the y-axis. If it had passed through this place, c would have been 1. Since the line passed through the 0 axis, then c is 0. Then how do I get the fraction? I find the gradient of this line. The gradient is, I just choose the top point here and the bottom point. The top point here and the bottom point. So I do y2 minus y1. If you trace this top point here, y2 is 2. and y is 0. So 2 minus 0 will be what I have on top. So I find the gradient of that line. See, I have y2 minus y1 over x2 minus x1. Now, my y2, because I just chose 2 points, this point here, you can choose any point, this point here and this point here at the bottom. So if you trace the highest point here on the y-axis, you get 2. The lowest one will be 0. So you get 2 minus 0. You say 2 minus 0 over, now x, trace down. Trace the point down. The highest point, if you trace it down, you get 4 for x. The lowest point is 0. So you now say x will be 4 minus 0. 4 minus 0. So this will be 2 over 4. Because 2 minus 0 is 2. 4 minus 0 is 4. 2 over 4. 2 over 4 simplifies to 1 all over 2. Divide here by 2, divide here by 2. It becomes 1 all over 2. So remember, that's my gradient. My gradient m is equal to 1 all over 2. So if I put 1 all over 2 here, and I put my x, remember c is 0. So no need to write 0. So that will be greater than or equal to, y is greater than or equal to 1 all over 2x. That's how we got this inequality. That's how we got this inequality. Y is greater than 1 all over 2x. Is that okay?
Yes.
So that's why this one we just use the equation of a straight line to get the equation. The equation of a straight line to get the equation. This one, when a line is sloping like this, it passes through the same number. Here is 4, here is 4. Just say x plus y is less than or equal to 4. Why did I say less than or equal to 4? Because the shade below the line. If the shade above the line, I will say greater than or equal to 4. So I will say x plus y is lesser than or equal to 4 for this one. I will say the next inequality, this is the first inequality. The second one is y is greater than or equal to half x. That's the second inequality. The third inequality will be 1, 2, 3. The third inequality will be x, just say x plus y is lesser than or equal to 4. This one is easy to determine. Once you have a line from here, once you have a line from here, from 4 here, going to 4 here, just like the one we did for corn and wheat, it was 10 to 10. So we say C plus W is lesser than or equal to 10. You remember that? So here is 4 and 4. So you just say x plus y is lesser than or equal to 10. The one we did just now, the previous one, if you remember, here we say, because here is 9, it's not 18. Here is 18, here is 9, half of 18. So you say 2y plus x is lesser than or equal to 18 for this one. Because 9 is half of 18, so it's 2 of y plus x that will be lesser than or equal to 18. Are you with me?
Yeah.
So these are the 3 inequality for this one. So the exam can come in any form. The exam can be in this form. They want you to write the inequality. The exam can be in this form. Sorry, the exam can be in this form. They want you to shade. This one we shaded, remember, we shaded. They gave you the inequality. They want us to shade the region. The exam can even be none of this. They will just give you this inequality. You will do this line yourself and you shade yourself. Okay, that one is taskier, the one we did in the previous section when we started. So you go to you go to get the line yourself and you go to shade yourself and so on and so forth. So that one is like double task. But there are some cases the exam is easier. They give you the inequality, they draw the line for you, they just want you to shade. And then the question could also be in this format, this one. They will draw the line, they will shade the region, they will show you the region, they just want you to write out the inequality. Is that okay? So we stop here for this one.